This video will cover identifying transformations in geometry when we are given an image and a preimage on a graph. So as you can see in the graph to the right, we have a preimage QRS and an image Q prime R prime S prime. And so our goal here is to identify specifically what type of transformation is happening here in the graph. And so in order to do this, we should look at the preimage points and the image points, meaning take a second to just list out those coordinates. We don't have an A here, so I'm going to erase that. We do, however, have Q, R, and S. So I'm looking at point Q and I see that it's located at 3, 1. Pause the video, go ahead and list these coordinates out yourself, and then check back in with me. So now you should have all 6 coordinates listed for QRS and Q prime R prime S prime. Our next step in identifying the transformation is to look at the rule, meaning what does x, y map onto? So when I'm looking at this, I notice that I go from a positive 3 to a negative 3. So it looks like maybe we're subtracting 6. But if I try that for the x values in R to R prime, 4 take away 6 does not land at negative 4. So I have to revisit what I think might be happening here. If I look again at 3 maps onto negative 3, I notice that I'm going from positive to negative, or in other words, negating x. And the same thing is true from 4 to negative 4. I now look at the y's. I go from 1 to 1, negative 1 to negative 1. So it looks like here I'm keeping the y exactly the same. So now, based on the rule, based on the picture and the coordinate points that we wrote out, I can identify specifically what type of transformation this is. And it looks to me as though it's a reflection over the y-axis. And it's important that we identify specifically, instead of just saying reflection, we say reflection over the y-axis. This way we know exactly what we're doing here in this transformation. If we take a look at example 2, we've got triangle ABC and triangle A prime, B prime, C prime. We're going to use the same process here, where we have to identify the transformation by looking at the preimage and the image coordinates, identifying the rule, and then we'll be able to answer that final step. So take a second to list your coordinates for A, B, C, and A prime, B prime, C prime, and then check back in with me. Now we have the coordinates listed for A, B, and C, so our next step is to take a look at the rule. X, y maps onto, and now I have to figure out what's happening with x's here, what's happening with the y's. So if I look here from negative 2 to 4, that looks like maybe an addition of 6. So now I'm going to test that on the next coordinate. Negative 5 plus 6 does in fact land me at positive 1. So now it looks as though I'm taking x and adding 6 to it. So now I have to figure out what's happening with y. Is it staying the same? Is it changing? And how am I changing it? Negative 5 maps onto negative 2. That looks to me like an addition of 3. Negative 2 plus 3 does in fact land me at positive 1. So again here I take y and I add 3 to it. If I'm adding or subtracting values, this is a translation, capital T. And in the little subscript here, in the little bottom part of the T, I have to list how I'm translating. I took x and I added 6, so I placed a 6 there. And I took y and I added 3, so I placed a 3 there. So again, it's important that we take a look at the coordinates and figure out the rule in order to identify specifically what type of transformation it is. Sometimes, yes, you can identify it from the graph, but it's very helpful to identify it from the coordinates. And when you list the coordinates, you at least have to do 2 sets of them, meaning A to A prime, B to B prime, because you can see here that we had to show that we tested the values for both A to A prime and B to B prime. As long as you test it for 2 sets, then you're okay. So that third C to C prime is kind of unnecessary, but it's nice to write it. In our last example here, we're going to again write the coordinates for Q, R, and S. Also Q prime, R prime, and S prime. Do that and then check back in with me. Okay, so now you should have the coordinates for Q, R, S, and Q prime, R prime, S prime. Just double check yours with mine. Our next step is to identify the rule. So here I have X, comma Y maps onto. When I'm looking at both Q and Q prime, I notice that I have the same numbers essentially. I have a 3 and a 1 and then a -1 and a 3. And so it looks as though they swap the spots, meaning Y comes first and X comes second, but that's not all that happened here. I took this Y and put it in the front spot, but it also became negated. That +1 turned to -1. The same thing happens in in R to R prime. -1 now becomes +1. So I negated the Y value, put it in the front, and then put the X in the back. When we do this, if we take a triangle and use that mapping, XY maps onto -YX, this is a rotation of 90 degrees. And you can see looking back at your picture, you're always allowed to look back at the picture, don't forget about that. It looks like we're jumping one quadrant to the left or counterclockwise, and that is in fact a rotation of 90. But I could not be sure of that until I tested or looked at least two sets of coordinates. On a Regents exam or on a Common Core exam, if you are asked to identify the type of transformation performed, the only thing that they're going to give you is this statement here: identify what type of transformation is performed. Meaning that they're not going to give you all of this setup here, the table with the preimage and image points or the rule. You will have to come up with this on your own. So please be aware that you will have to do more of this work on your own than what I've scaffolded here for you. Feel free to pause the video and rewind if you need to. Otherwise, happy practicing.